Hello guys, welcome to Ramta Solutions. Today we are talking exponential graphs. Because we are in grade 11 now, let's begin with some revision from grade 10. In grade 10 you had said y equals a times b to the x plus q. Alright? Now, what you had said was this guy represents, okay, let me reduce it. This guy represents vertical shift, which is shifting up or down. If q is positive, the function will move up or shift up. If it is negative, it will shift down. We also said he represents horizontal asymptote. Right, we also said he represents horizontal asymptote, which is basically a horizontal point or line where the graph does not exist. This has the formula y equals q. So when you are asked for asymptotes, you will say it is y equals q. This a, I will speak much about it when we look at its relationship with b. When it's positive, the graph lies above horizontal asymptote. When it is negative, the graph lies below horizontal asymptote. Okay? Now, let's look at it now in details. The relationship between A and B, to be precise. Now, let's look at it when A is positive. Maybe let me shift it down a bit. When A is positive, and then when A is negative. Okay, and then I will also look at when B is greater than 1, and then when B is greater than 0 but less than 1. I want to add something. Remember guys, for this graph to be an exponential, b must never be equal to 1 and it must also be greater than 0. Okay, it must not be equal to 1 and it must be greater than 0. Okay, good. Now, having said that, let's get in here. When A is positive and B is positive, I will give you an example. An example is y equals 2 to the x. Your graph would look like this. Okay, it would look like this. Okay, now let's try when A is positive but B is greater than 0 but less than 1. Example would be y equals half to the x, which is similar to saying 2 to the minus x. Your graph would look like this. Okay, your graph would look like this. Now, what about when A is negative? As you can see, this graph is above the asymptote. Remember here, asymptote is y equals to q. What is our q? Our q is 0. Y equals 0 is here. The graph is above it. Now, y equals negative 2 to the x. Our graph would look like this. Right? Y, x, 0. Right? Now, when, let's try here, y equals the very same one, but I will put a negative, half to the x. Of course, I said it's 2 to the minus x. Our graph would look like this. Right? Can you guys see this? Now this is how the graphs look like. Now you can see that when A is positive, the graphs lie above the horizontal asymptote. When A is negative, they lie below the horizontal asymptote. Okay? Alright, so let me maybe generalize this in a way that would be clearer for you. We will say, so when A is positive, your graph could be like this, could be like this, or could be like this. This is when B is greater than 1. This is when B is greater than 0 but less than 1. Now when A is negative, remember this now looks like this. And so when you look at this looks like one is a reflection of the other. Can you guys see that? It looks like one is a reflection of the other. Okay? And this is how you will be able to tell if, for example, you are finding your equation, if the shape makes sense, or if your answers are making sense as well. Okay? Right. Now, let's look at domain and range. Let's look at domain and range. So with domain and range, domain is set of input values. All x values will always return a y value. Think of any x value you can think of here. If you can put x to the 2 to the 100 million, whatever, it will always return a value. Okay, this means all values of x you can think of are possible. So we can therefore say our domain is x is a set of is an element of real numbers, and we are okay. With the range, I want you to look at something. Y is an element of real numbers, but there is a condition. Look at this. It can accept all y values, but be careful, it's not necessarily all. It can only, in fact, allow y values that are above the horizontal asymptote. What is our horizontal asymptote? Q. But this is only the case when A is positive. So I will expand on this. Before I can even do this, let me say, when A is positive, y is an element of real numbers, but y must be greater than q. Now let's go look at a case where a is less than 0. Let's look at the case where a is less than 0. It can allow y values that are below the horizontal asymptote. Can you see that? So it can allow all y values that are above the horizontal asymptote. So we can say, oh, okay. So this means y is an element of real numbers, but y must be less than q. This is what you did in grade 10. So remember, using these formulas will help you a great deal. Using these formulas will help you go a great deal. You will basically get all your marks. Okay? Now, let's move to grade 11. And by the way, domain and range, the definition will still be the same in grade 11. So, now let's talk grade 11. We say, here, it goes, it gets expanded a bit. So let's expand it. So, A, B, and Q, they still mean the same thing. But you can see we have something called a P here. Now, this P represents what we call horizontal shift, or what you call horizontal translation. Okay? Horizontal shift. So this is basically movement from the left to the right, or vice versa. Right? Now, when P is positive, this graph shifts to the left. When P is negative, this graph shifts to the right. This is all that you need for grade 11. So this is the only thing. This P, all it represents is horizontal shift and nothing else. Okay? Great stuff. Now, let's try some examples. Let's have fun now. Example. Okay, let me see. We addressed everything. And now example, determine or state the range. I won't say the domain because it's obvious. It's just X is an element of real numbers. State the range and asymptote of what? Of the following. Let me say of the following. Of the following. What is that following? We have 1 f of x equals 5 times 3 to the x plus 1 minus 1. Number 2, f of x equals negative 5 to the x minus 2 plus 1. Number 3, f of x equals 3 over 2 to the x plus 3. Okay, now let's answer the questions. Oh boy, I like this. Number 1, f of x equals 5 times 3 to the x plus 1 minus 1. What you know is that a is 5, which means the graph lies above the x and the asymptote. B is 3, so I'm expecting our graph to look like this. P is 1, this means it is shifting to the left, and then Q is equal to negative 1, meaning it's shifting down. Now, our range, I remember saying y is an element of real numbers, but y, wait, a is positive, right? So since a is positive, y, remember I even showed you how it would look like. So it must be greater than q, right? So what does it mean? It means our range is y is an element of real numbers, but y is greater than minus 1. Remember, when a is positive, the graph lies above the asymptote. Now, let's talk asymptote. We only have one asymptote for this graph, which is the horizontal asymptote. We said it is y equals q. Let me confirm. Yes, it is y equals q. Now, what is our answer? Our answer is y equals negative 1. We are sorted. Okay, moving on. Let's go to number 2. Number 2 said f of x equals negative 5 to x minus 2 plus 1. This is, again, a is minus 1, b is 5. Remember, guys, for exponential graphs, your b is never negative. Remember, b should be greater than 0. Okay? Now, p is equal to negative 2, meaning it's shifting to the right. Q is equal to 1, meaning it's shifting up. Now, our range, by now you should know y is an element of real numbers. Ooh, I must say, I'm expecting our curve to be like this. Our curve to be like this. So y is an element of real numbers, but y is less than q, right? This you should know. Now we say y is an element of real numbers, y is less than 1. We are good to go. Okay. Number 3. F of x equals 3 over 2 all to the x plus 3. With this one, a equals 1, b equals 3 over 2. So this means our graph looks like this. P equals 3, shifting to the right, it shifts to the right. Q is 0. Okay, now our range, it'll be y is an element of real numbers, but a is positive, so it'll be greater than q. So our answer is y is an element of real numbers, but y is greater than 0. Our asymptote, oh boy, I forgot to cover the asymptote in the previous one. Here, our asymptote, y equals q. Sorry about that, I'm squeezing it. Y equals q. Y equals q. So this means y equals 1. This is our asymptote. Here, again, I'm going to say y equals q, just so I remind you. Therefore, this means y equals 0. Okay? This means y equals 0. Happy? Awesome. Now, let us find the equation. Okay, let us find the equation. I will say, given that y equals negative 2 times 3, okay, to the x plus p plus q is the equation for the graph below. For the graph below, find p and q. So here is your graph. Maybe let me do it like this. By the way, I expect this graph, since a is negative 2 and b is 3, I expect this graph to be like this. But okay, let me continue. So the graph is like this, and this is 6, and then this is 6, and then this is 2. By the way, this is y-axis, this is x-axis. Now, what we can do, we know y equals negative 2 times 3 to the x plus p plus q. So what we can see from this graph is that it has a horizontal asymptote, which is the value of q, which is 6. So y equals negative 2 times 3 to the x plus p plus 6. Now, there is another point given here, which is 2 and 0. So point is 2 and 0. Can you see it? This is an x-intercept. So where there's x, I will put 2. Where there's y, I will put 0. So this is 0 equals negative 2 times 3 to the 2 plus p plus 6. Alright? So what do we have? We have 2 times 3 to the 2 plus p equals 6. Okay, now dividing by 2 throughout, we will have 3 to the 2 plus p equals 3. Right? Now, this is 3 to 1, obviously, 3 to the power 1. So we have 2 plus p equals 1. What does it mean, therefore? It means that p equals, I believe it means p equals negative 1. And then we are sorted. With that being said, this is how you find your equation of the exponential graph. So this is it. See you next time. Bye bye.